In this video, I'm going to review the power rating problems and generator problems. Let's look at one of the power ratings. We'll look at number 1. Before we start, remember in the PowerPoint, the constants for a single phase generator is 0.7. For 3-phase, it's just 1. So, number 1 is asking, what is the power rating for a single phase generator capable of delivering 100 kVp at 400 mA on the tube? So we're going to multiply 100 kVp times 400 mA. Since we're doing a single phase, we have to multiply in the constant, which is 0.7. Well, if you notice, kV and mA cannot be multiplied together. So we have to use our unit conversions and take them out of kilo and milli and put them into their respective units. After converting kilovoltage to voltage, you should have gotten 100,000. When you take milliamperage to just amperage, you should have got 0.4 amps times 0.7. And when you multiply all of that together in your calculator, you should get 28,000. Since it's power, it's measured in watts. Now, we have to change it back into kilowatts. So going from the unit, moving up, we're going to move the decimal place to the left 3 times. Your final answer should be 28 kilowatts. And don't forget to circle it on your test whenever you answer a question, so the instructor grading your exam knows what your final answer was. Instead of trying to draw it out on the Word document, I figured I would just hop over to my key and just explain these problems with the key. So again, draw a 1-phase 2-pulse full-wave rectified generator output during a 0.20 second exposure. On the drawing, label the time, and I kind of highlighted it so you could see where I'm getting everything from. Label the time, how many pulses per cycle. We know with a full wave, 2-pulse full wave rectified generator, 2 pulses per cycle, and 120 pulses per second. Well, we only want to draw 0.20 seconds of that 60 seconds. So right here, I did 60 times 0.20. That's how I knew how many cycles I have to draw. 2 pulses per cycle, you're going to draw 24 pulses. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you can separate, I separate each cycle by a line so I knew I drew the right amount. And that's basically how you're going to demonstrate what a 1-phase 2-pulse full wave rectified generator looks like. Alright, let me explain the 6-pulse full wave rectified 3-phase generator. This one is stating draw a 3-phase 6-pulse full wave rectified generator output during a 0.10 second exposure. On the drawing, label time, how many pulses per cycle, and how many pulses per second. It's already a given, 6 pulses per cycle, but still make sure you include it, as well as the 360 pulses per second. Instead of drawing 360 pulses, because you wouldn't have enough room for that, we're only going to demonstrate 0.10 seconds of that exposure. So 60 times 0.10 is 6, so that's how many cycles we're going to draw. There's 6 pulses in a cycle, we're only going to draw 36 pulses. Remember, with a multi-phase generator, the deflection never drops to 0, because the next wave is going to pick up that voltage. So as you see here, there should be 6 pulses, and I just separated my cycles again. So I have 1, 2, 3, 4, 5, 6 cycles and 36 pulses.